This topic, the refraction happening at the spherical surface, is one of the important topic for the term to CBSE board exam. The blue colored portion represent a curved surface with center of the curvature as C. If you take this arc PA as one complete sphere, center of that sphere is C. P to C is the radius of curvature. The center of the curved surface, geometrical center, half point, is P, that's a pole. Any line passing through PC to the right and left represent the principal axis. The blue colored region represents a denser medium of refractive index N2. The medium with refractive index N2 is placed in a surrounding medium of refractive index N1, the white colored region. For the image formation, we are considering a point object O on the principal axis. Minimum 2 light rays you need. One light ray moving along the principal axis. It falls on the surface along the normal, so no refraction, will go straight. Another light ray falling on any point on the curved surface, this is convex spherical surface, can be down or top anywhere. Instead of going straight, since the light is moving from rarer to denser medium, it bends towards the normal from the straight path. So the normal is always the line passing through the center for a sphere. So this C, the black dotted line from C represent the normal. So instead of going straight, light ray bend towards the normal and meet at I, where the two light rays starting from O meet, that's an image point. P to O is U, the object distance. P to I is V, the image distance. P to C is R, the radius of curvature. There are two basic assumptions we apply during the derivation. The angles made by the object light ray. OA is the object light ray with the principal axis, is marked as alpha. Same way, angle made by the normal with the principal axis is marked as beta. The angle made by the image light ray, AI is the image light ray with the principal axis, that is marked as theta. The angle of incidence is the angle made by the incident ray with the normal. It's angle of incidence. Angle of refraction is the angle made by the refracted ray with the normal. The assumptions: we are not taking an object with a size. The object is point size and is placed on the principal axis. So point object placed on the principal axis. Aperture of the refracting surface is very small. Aperture means the diameter of this refracting surface from top to the bottom is practically very small. This is shown large for understanding. So if it's very small, PA, you feel PA to be an arc, but PA can be taken as a straight line because P is very close to A. For a small aperture surface, A is very close to P. So you can take PA as a straight line, even it's feeling to be an arc. That's the meaning of the assumption. And when A comes close to P, the alpha, beta, theta, I are all are small angles. This is a concept for small angles. Sine theta can be taken as theta. Theta in general, not only this theta, sine I can be I, sine R can be R. Even tan alpha, tan beta, tan theta, all can be taken as respectively the angle. So small angle, sine theta is theta, tan theta is theta. It's applied on the way. Now we apply Snell's law. Sin I by sin R, sine of angle of incidence by sine of angle of refraction is n2 by n1. Just now for small angles, small aperture, small angles, sin I will be I and sin R will be R. So you can substitute and cross multiply. I by R and n2 by n1. So n1 will go left, n2 R will go right. So n1 into I is equal to n2 into R. Then from this triangle OAC, the exterior angle I is a sum of the opposite interior angle. That means I equal to alpha plus beta. From the next triangle, triangle ACI, again the exterior angle beta equal to R plus theta. So beta is R plus theta, but R will be then beta minus theta. We substitute this alpha plus beta and beta minus theta instead of I and R in the equation. N1 I equal to N2 R. So N1 is N1, I is equal to alpha plus beta, N2 is N2, R is beta minus theta. Open the bracket. N1 alpha plus N1 beta equal to N2 beta minus N2 theta. By seeing this, take the beta to the right side together, both betas, and theta to the left side. So that will give you N1 alpha already here, N2 theta come to the left, N1 beta go to the right. So take beta common out from both, left side remains the same. Now for small aperture, we can find the value of alpha, beta, theta as tan. For small aperture, alpha is tan alpha. Tan alpha is opposite side PA by PO. Same way tan beta will be beta, which is PA by PC. Tan theta will be again PA by PI. All can be taken as respectively the angle. Now substitute alpha, beta, theta in this equation. So alpha will go as PA by PO, theta will go as PA by PI, beta will go as PA by PC. You can see PA is common in all the three. So you can cancel PA. Once you cancel, it will be N1 by P plus N2 by PI equal to N2 minus N1 by PC. Then find PO. PO is U, PC is R, PI is V. If you apply sign conventions, PO equal to minus U, PC and PI will be positive R and V respectively. So PO equal to minus U, PI equal to V, and PC equal to R, both are positive. If you substitute this back here, N1 by minus U plus N2 by V equal to N2 minus N1 by R. That's a required expression for refraction at a single spherical surface, which can be used to find the image position or the object position or the radius of curvature or N1, N2 if the other values are given. This is done for a convex surface. It's applicable to convex surface or concave surface forming real virtual images, all with proper sign conventions. As a sample question just to understand. Light from a point source in air falls on a spherical glass surface. Refractive index of the glass surface is 1.5 and radius is 20 centimeter. The distance of the light source from the glass surface is 100 centimeter. At what position the image is formed? Here they didn't say which type of surface. We are assuming convex surface. As per this diagram, point source is O. Glass surface is this blue medium. So N2 is 1.5. Air means N1 is equal to 1. Radius of curvature is 20. PC is to the right or parallel to the incident light, it's positive 20. Then distance of the light source from the surface is 100. So the PO is minus 100. What position image is formed? You're supposed to find V. So N1 is equal to 1 because it's air. N2 is 1.5 because glass is 1.5. Then R is plus 20 because sign convention P to C is positive here, parallel to the incident light towards right. Then your aim is to find V. So go to the formula directly. Formula is minus N1 by U plus N2 by V equal to N2 minus N1 by R, same formula. N1 is 1, minus already here. You have to give additional sign conventions when you solve the questions. All the values should be given to their own signs. The U value is minus 100. Then N2 is 1.5, V we don't know, 1.5 minus 1 by R is plus 20. The U value is minus 100 because it's formed on the left side, which is against the incident light. Add here. You take 1.5 by V, this is solved by 0.5 to the right, become plus then minus finally. LCM can get VS 100 centimeters. That means image is found on the right side, 100 centimeter to the pole. This can be another question. You can try as homework. The answer is coming to be minus 180. Means image is formed 180 centimeter on the left side against the incident light. Here they given the value of U. U is equal to minus 100 centimeter.